Okay, so students, according to your question, the total area of land that is available that has to be irrigated is 300 hectares. Okay, I'm writing it small h, small a, right? So the CCA, the cultivable commanded area that can be cultivated, okay, out of this total land, total area, it's 80% of CGA. 80% of the total area is cultivated. Okay, so CCA will be 80% of CGA. Okay, so it will be 80% of CGA. CGA is 300. So, sorry, GCA, gross commanded area. Sorry, gross commanded area. Okay, so you remove this percentage sign. Okay, divided by 100, and here you write 300. Okay, so you calculate, you will get in hectares. Now there are two crops. Okay, one is wheat and one is rice. Out of the CCA, out of the cultivable commanded area that can be cultivated, okay, 40% is cultivated in CCA. Okay, so it'll be 40%, remove this percentage, divide by 100 into whatever CCA you have found out, you put the value here. Then you will get the answer here, which is in hectares. It is in area, that's why the unit is in hectares. Okay, now the area under rice, 20% is being cultivated from CCA. Okay, again you put the value of here. Okay, so 20% divided into CCA, so you will get the value here in hectares. Okay, area in hectares. Now the first part of the question, you have to find the discharge of the outlet. Okay, so the discharge of the outlet can be found out from area to be irrigated in hectares divided by the outlet factor in hectare per meter cube per second. The outlet factor, okay, in the question is given 1600. Okay, so you put the value here. Now, area to be irrigated in hectares. How much area do you need to irrigate? Now, there are two crops, right? The wheat and the rice. So now we'll find first for the wheat. Therefore, discharge of outlet for wheat, okay, it's area. So the area under wheat, when you have found out from here, you put it here, okay? Then you will get in meter cube per second. Discharge unit is meter cube per second. Or you can see from here, hectares with hectares, it gets cancelled out. Left is meter cube per second. Okay, it goes up, right? Now, discharge of outlet for rice. Now you will find the discharge for rice. Okay, again, it's area to be irrigated in hectares. That means the area of rice to be irrigated in hectares. Okay, you find it out here and you put it here. And the outlet factor, okay, for rice, it's 900. Okay, so you will get some value here. Now, the second part of the question, you have to design the discharge head. Okay, for designing the discharge head, you have to see which discharge is giving the maximum value. Either the discharge for wheat is giving the maximum value, let's say this is equation 1, or the discharge for rice is giving the maximum value. Either of these, you will have to design your irrigation, okay, channel, and you have to take the value which is higher than the other. Let us say the discharge outlet for wheat is greater than the discharge outlet for rice. Let us say the value that you got here, just for explanation, in equation 1, is greater than the value you got here. Okay, so let's say the discharge for outlet, it's greater than the discharge for rice. So we will take the discharge of the wheat. Okay, so in step 3, right, discharge for, I'm just saying assumption, okay, discharge for wheat, let's say this value you got greater compared to equation 2. Okay, so discharge for wheat, crop is more, so taking the discharge for the canal as, okay, whatever value you get here, you write it here, okay, plus the losses, how much losses it's there given in the question. Okay, so next line you write, so discharge at head is, the discharge at hand, okay, is you write down this value, okay, that you got here and here into 5% of the losses. So 5%, you remove the percentage, it will be divided by 100. This value here, remember, you will have to write the value which is from here. Okay, that means the greatest, let's say for the wheat, let's say for equation 1, the discharge for wheat, I'll just write here, for wheat crop, it's more, so taking the discharge, the design discharge for channel as, okay, let's say some value here, it's A, okay, let me write here, let's say this value comes out to be A meter cube per second, so here you will write down the value of A, which is in numbers, okay, and then you will write down here whatever value you're getting from equation 1. From equation 1, you put the value and you will get the discharge head.